Hi everyone, good evening. I hope you're doing well. So let us start today's session with a quick recap of last lecture, lecture 4. Now, before we proceed, let me ask a question. How many of you are understanding what all concepts have been discussed so far in these sessions? Please type 1 in chat box. If you are understanding and enjoying your chemistry class, okay, please type 1 in chat box quickly. Great. I hope all of you should do. Wonderful. Okay, I'm audible properly? Type 1 if I'm audible properly. Please type 1 in chat box. If any noise or any problem is there, let me know. We can fix it. Okay, great. So if everything is fine, let's initiate the session. And in the last class, we have talked about, in the lecture 4, we have talked about these things, which are percentage by weight, right? So if you recall what was percent by weight, it is weight of one substance divided by total weight into 100. So mass of one upon total into 100 is called percentage by weight. It is used if you have, let's say, two things and you have mixed them, you can always use this method. Now, the second thing which we discussed was percentage by volume. It is volume of one particular liquid upon total volume multiplied by 100%. The third thing is mole fraction, define add moles upon total number of moles. Can you recall these things? If yes, please type 1 in chat box. So these things we know very clearly. Everyone. Yes, sir, very clear. Okay, Adya, very good. All students understanding this? Great. Now, the next thing is solute, solvent, and solution. So in the last class, we have learned that when we talk about solution, what is solution? So solution is a homogeneous mixture. This word was very important. Homogeneous mixture of solute and solvent. Solute and solvent. And when I use word homogeneous mixture, I have told very clearly that this is representing a common phase. Okay. Same phase. After mixing solute and solvent, we come to a common phase. I'm using a word phase. Okay. Now, what is phase? We will learn this in more detail. You can say, like they will have one kind of image or one kind of what you call appearance. So solute, let's say you have solid. Let's say your solvent was liquid. So your solution, which you're going to form, is mixture, which is homogeneous mixture of these two things. And this gives us a common phase, right? I hope this part is very, very clear to all of you. Any problem in this? Any issues in this? If this is clear, type 1 in chat box. I can see attendance is little low today. I request many teachers to please connect with students. Why it is slightly low? So maybe they are joining, but we are just reviewing the last class. Okay. And then we also discussed about conservation of mass. आपके पास solute है, solvent है, you mix them, you get solution. Mass of solute plus mass of solvent will always be mass of solution. There is no problem in that. It has to be. But there's nothing called conservation of volume. I think all these things we have done in the last class. If understood, please type 1 in chat box. Everyone, type 1 in chat box right now. Or you can show some thumbs up that, okay, this much you can understand, you have revised, you're comfortable with, right? Okay, now I have another question. I have given you some assignment. Home assignment 1. How many of you have started home assignment 1 at least? Okay, those who have started can type 5. If you have started, type 5. If you not started, type 6. Komadi, Anunya, Aradhana, Jaswant, Shaurya, Yuvraj, Divyansh. Very good. They have started. Ishita has not started. Okay. Very good, bache. Wonderful. Okay. Yeah, Arshdeep, you want to say something? Yeah, tell me.
Sir, actually, I was searching for the homework which you have assigned on the Google Classroom, but I was not able to find it. Could you please tell where it is?
Oh, okay, so go to lecture 3. In lecture 3, I think you'll find one book 1 mole concept. Okay?
Yeah.
And book 1 mole concept, if you check, page number 6th or 7th, it will start. Right?
Okay.
Just do that.
Okay, sir.
Okay.
Thank you.
Fine. So those who could not find, they can refer this instruction and they can find out. Like, see, lectures are given, everything is given, just find it out. Home assignment 1. Okay. In book 1 mole concept, we can find. Okay, let's proceed further. So today we'll be starting with this question. And I think this was your home assignment question for the last class. How many of you have solved this question? If yes, please type 6 in chat box. Sir, we have solved this question in the last class. Type 6. This was given at the end. Those who have not tried, type 7 in chat box. Those who have not attempted, type 7 in chat box. The reason can be anything, but if you have not solved, please type 7 in chat box. Okay, so almost all of you have attempted. Let's see what will be the solution of this. Question is, we have 90 grams of glucose, right? 90 grams of glucose. And glucose formula is C6H12O6. Please note down. Glucose formula is C6H12O6. Okay. Mention that, note it down. Fine. So we are given 90 grams of glucose, which is dissolved in 250 ml of water. 250 ml of water. Everyone please type in chat box, what is density of water? How much is density of water? Type in chat box. If you know that, we have discussed this number of times. Density of water. Everyone in chat box. Please type. Fast. Okay. 1000 kilogram per meter cube or 1 gram per centimeter cube. Fine, that's completely okay. Or 1 gram per ml, can I say? 1 cubic centimeter is 1 ml. So we can say 250 ml is 250 gram. Safely for 4 degrees Celsius, this assumption works true. Nothing is mentioned. I can assume that it is 1 gram per ml. So I'm assuming density is 1 gram per ml. After writing this, you have 250 grams of water. Okay, now, how many of you identify which is solvent, which is solute? Yes, what is the solute? Can we say the one which is being dissolved? Answer is glucose. So what becomes solvent? Everyone chat box. If glucose is solute, what becomes solvent? Wonderful, amazing. Solvent becomes water. Solvent becomes water. That's perfectly all right, great. So we have solute as glucose, solvent as water. Question number 1 is already solved. Question number 2, calculate the mole fraction of solute. Question number 3, calculate the percent by moles of solvent. Question number 4, calculate the total weight of solution if the reaction is occurring in a closed vessel. So you are mixing glucose with water. Can we apply conservation of mass? Mass is conserved. And since mass is conserved, I can say this is total 340 grams. So can I say option number 4 is also solved? Yes, please type 1 in chat box if 4 is clear. Everyone? Very good, बच्चे. सब लोग आंसर कर पा रहे हैं. Excellent. Now, if this is solved, can we solve question number 2? Let's try. So what are moles of solute? Moles of solute would be, yes, weight of solute is how much? 90 grams. What is molecular weight of glucose? So molecular weight of glucose we can solve for. Molecular weight of C6H12O6 would be 12 multiplied by 6, 1 multiplied by 12, and how much? 16 multiplied by 6. So this you add 72 plus 12, 84 plus 96. Right? How much it comes? It should come total 180. It must come 180 gram per mole. This will be the unit. Isn't it? So we can say that this is 180 gram per mole as the value or as the overall amount that we can get here. Isn't it? Is this fine? Any problem in this? So we can divide it here. And you get half mole of glucose. Any problem in this part? Everyone, it is clear? Type 1 in chat box if this is clear. Any issues you can ask. Very good. All of you please type. See, this is very important that you give the feedback. Sir, we understood everything. Okay, excellent. Wonderful. Okay, great. Right. So if all of you got this answer, then we can say that, fine, we have information regarding moles of solute. Do we have information regarding moles of solvent also? Moles of solvent would be, so 250 gram solvent is there and water's weight is 18 gram per mole. Is that it? Clear? 250 gram is the mass and 18 gram per mole is the value of water's molecular weight. Is that clear? So if this part is clear, we can say that we know moles of solute, we know moles of solvent. Let me call this N1 and this is N2. What is my answer number 2? So answer number 2 will be nothing but N1 divided by N1 plus N2. Simple. Half divided by half plus 250 plus 250 by 80. And I think all of you have very good maths and you can solve this question. If this part is clear, if 2 is clear, you can type 2 in chat box. If 2 is clear to everyone, please type 2 in chat box quickly. Sir, 2 is clear, completely clear, no doubt, no problem, nothing is there, right? Great. Okay, so those who understood 1, 2, and 4, all 3 parts, they can type 1, 2, 4 in chat box. Everyone participate. 1, 2, 4. If you understood 1, 2, 4, all 3 parts. Great. Amazing. Now, can third part you guys solve from your end? Third one. Let's try third one. Okay. Let's see how we're going to solve third one. Everyone, please try to answer third one. Calculate the percent by moles of solvent. Yes, I'm expecting your answer in chat box. Fantastic. Gargi ma'am is here with you. Okay. So in case of any problem, anytime, you can always reach to your mentor teachers. They will definitely support you. Okay. Definitely. Anyways, so this is clear. I can proceed to the next thing. And this answer is expected from everyone. What is the method for this answer? What are you going to do in this part? Percent by moles of solvent is there. So solvent moles divided by total moles into 100. This is the maths you have to solve. Can you close this question, all of you? Yes. If you come like confirm, then only I'll proceed further. So we can close this question. No problem in this question. Everyone, tell me yes. Okay, great. Excellent. Now, if this is clear, I can go to the next set of question. Calculate the percent by weight of glucose in the above solution. The same question is continued. So what is amount of glucose? 90 gram. What is amount of water? 250 gram. So I can just note it down for reference. Read the first part. Calculate the percent by weight of glucose. As I always say, the role of teacher is very important. And as a teacher, you always ensure that our students learn each and everything. Okay. So these concepts we have learned from our teachers and we are delivering those same things to you also. So idea is whatever we understand, we should be in condition to express and solve questions. That's what is key thing. Let's try first question, everyone, together. Question number 1. So question number 1, what's the language? Look at the language of the question and try to solve. Percentage by weight of glucose in the above solution. So what shall be the answer for this question? How are we going to solve? We can say mass of glucose upon total mass into, yes. So let's complete that. First part, it is 90 gram of glucose is there. Total mass is 340 gram multiplied by 100. Very simple, isn't it? Can you complete this question, everyone? Yes. So definition already we have done. It is mass upon total mass into 100. Right. Come to question number 2. Calculate the percent by weight of water in the above solution. Let us see what students have done for the question number 2. Let us see what they have done for question number 2. So I'm just expecting your answer in chat box. Try to complete. Yes. And I request all of you to not use calculators, because if you use calculator, that will be a problem. So don't use calculator in any form in the discussions. Don't use calculator. Try to calculate yourself. Let's try second part. Percent by weight of water in the above solution. So we can say 250 divided by 340 into 100. 250 divided by 340 into 100. All right. That will be the second part. Everyone is getting this answer? Yes. Very good. But see, answers are coming different from different for different students. So please solve it till the end. Very nice. 250 upon 340 into 100 would be how much? Yes, correct. So it is 2500 by 34, which is 1250 by 17. Okay. 73.4, approximately 4, right? Or 5 maybe. Yeah, because 9 is there, right? So in this range, it should be. Just check it and confirm if this is clear. Vaibhav, Mahapatra, are you getting answer, beta? All of you getting answer in this range? Okay, great. Everyone getting answer? Right. So we solved this question completely end to end. Now quickly come to third question. First is done, second is done, and these two questions are already done here, all 4. So now we are moving towards question number 3. And physical chemistry is all about applying the concept. It is not just knowing the concept, it is also application of the concept. We need to apply, we need to see that whatever we have learned, is it applicable? How are you using it? That's make the whole difference. So third question is 500 gram of a 20%. So I'll do one thing, I'll just take this part on the other page. Okay. So this is the question. 500 gram of a 20% solution was cooled. 50 gram of solute is precipitated. What is the percent by weight of the remaining solution? That's entirely different question. Okay. It is not linked with this. It is entirely different set of question. So let's try this question, everyone. Take your time. Take 1 minute time. Think carefully. Try to answer. $500 gram of a 20% solution was cooled. 50 gram of the solute is precipitated. What is the percent by weight of the remaining solution? That is a question. Okay. So first of all, what is this 20% value? Is it percent by weight? Is it percent by mole? What is it? What do you think? Type in chat box. If nothing is mentioned, what we have to consider? All of us. Very good. Percent by weight. It is percent weight. Nothing is mentioned. Percent by weight is understood. So you have 500 gram solution, which is 20% by weight. 20% by weight. Now, what is meaning of it? 20% by weight of whom in the solution? So we can say 20% by weight of what? Solute, of course, because that's the definition. If nothing is mentioned, it is always about solute. Okay. So it's not written, but it is written in a way, indirectly. Please note down this much. All right. So let me bring it slightly this side. That should be visible to everyone. So what is 20% of 500 gram? Can we calculate? This mass is how much? 500 into 20 by 100, which is 100 gram of solute. Correct? So in total, you have 400 gram of solvent and 100 gram of solute. That's my understanding. Clear this one, everyone? This part is clear, बच्चे? सभी को समझ में आया यहाँ तक? शुरुआत में हमारे पास क्या है? 100 gram of solute है और 400 gram of solvent है. ये सबको समझ में आती है? I'm just talking about the line number 1, nothing else. I'm just talking about this line. This line alone. That should be clear. Okay. Now the second part of the question. 50 gram of this solute is precipitated. So if 50% is precipitated, 50 gram is remaining as solute. Because 50 has gone to precipitation. Precipitation means you have removed it from the given system, right? It is deposited in a solid form. It's not part of the system. Removed. Correct. So if that is clear, then I think we can understand the question, right? Yeah. So this is clear. Can we say 50 gram remains? How about this 400 gram of solvent? This also remains. 400 grams of solvent remains. So what's the current mass of solution? Type in chat box. Current mass of solution is how much? कितना solution अपने पास अभी? 500 ग्राम था. 50 ग्राम आपका deposit हो गया यहाँ पे, right? So what is remaining? Please type in chat box. If you want to ask question, please raise hand. Don't speak like this. The process is very simple. You have to raise hand. I'll give you mic. Don't speak in between. Yeah. Anyone having any doubt? The process is very simple. You have to raise your hand. I'll give you mic. You can speak and discuss. Yeah. Saida Ahmed. Just a moment.
So we just basically for the solvent solute, we just how do we get 50 grams by?
Okay, wait, Beta. I'll explain. See, you are given 500 gram of 20% solution. See the starting of this question.
Yes, sir.
That means this 500 gram of solution, you have 20% by weight of solute, which is how much? 100 grams of solute, isn't it?
Yes, sir.
This 100 gram of solute is there initially. But when you cool it, 50 gram of solute gets precipitated. Precipitation is outside solution. It's not the part of solution anymore because solution is in one phase. Precipitation is outside, right? So 100 was there, 50 got out. So what is remaining? 50. That remaining 50 and 400 of solvent which was there. Because 500 is what? 400 plus 100 is 500. Out of 150 gone. So what is remaining? 50. And this 400 is as it is. So what is the current mass of solution? That was the question. I think everybody understand now. Clear? So what's the answer? We have total 450 gram. I think this should be clear to everyone. If yes, please type one in chat box. Everyone comfortable with this? We have total 450 grams of solution. In 450 grams of solution, what is the current amount of solute? Yes. Just 50 gram. 50 is solute, 400 is solvent, 450 is solution. Clear? Now read the question. What is the percent by weight of the remaining solution? The solution that we have right now. What is the percent by weight of the solution? So we can say 50 is solute, 450 is total into 100. And that can be solved as 100 by 9%. Check that. Can you complete this question? If yes, you may type 3 in chat box. Those who understand, please type 3 in chat box. So question started like this, that you have some solution. In that there was solute and solvent, but some solute went out. So remaining solvent and solute, they're asking. Yeah, Kamadi, what's it up?
Sir, in the question, they have not specified, like they say it is about solute or solvent.
Exactly. So whenever nothing is mentioned, if 20% solution is mentioned, now think 20 and 80, what is less, what is more?
20 is less, that is solute.
Correct. Otherwise, 80 had been the other part. 20 is one part, 80 is other part. So if nothing is mentioned, by default, you have to take the solution as this part as solute only. If nothing is mentioned. As we discussed, if nothing is mentioned, we always take density of water as 1 gram per ml only. Same logic is, if they mentioned 500 gram of a 20% solution, by default, it is percent by weight, and by default, it is solute, right? Had it been solvent, they will give you written that this was solvent. Is that clear, Pamadi? Okay,
Yes, sir.
all right. So this question is clear to everyone? Any doubts in this question? I hope all of you understand that. Very good. So up to this point, I want to run one small poll to understand your clarity. Whatever we have discussed, have you understood, everyone? Excellent. This is very important thing because your thought process should be aligned with our discussions. It should not be missing any point. Okay. Very good. All of you, please input. So still, I think few members have not given input. Please do it quickly. And we close this. So here's the result. Almost 97% students understood everything. Few students have found difficulty. We can discuss separately as well. Not a problem. So this is clear. This discussion is clear. And this discussion is also clear. Okay, let's proceed further. Now read this question. A liquid M is dissolved in another non-miscible liquid N. Total volume of the liquid mixture is 700 ml. If the percentage volume of M is 35%, calculate the volume of both the liquids. It's a very simple question, and I will not help you in this. I expect that you will solve yourself this question. Let's see. Can you do that? Try. Read it. It is simple. So every time when you read a question, always try to underline key points. Okay. Liquid and non-miscible means which are not like getting mixed easily. Total volume of mixture is, later it is 700 ml and M is 35% volume of both the liquids. Try. Try to solve. I'm getting some answers here. Very good. 245 ml. Very good, Yuvraj. It is volume of which part? Which liquid? M or N? Excellent. It's a very simple question, everyone. It's a very simple question. If you spend a little bit of thought here, you can understand that what I'm talking about. Very simple question. Today, I think few students are like going for the weekend or something, right? Strength is less, slightly less. So we have more students in this class. We expect more students to attend the class. And missing a class without any, what do you call, very important thing, a very important task is very, very dangerous. Don't do that. If you're missing a class, there should be a valid reason for this. ऐसा नहीं कि बस कुछ भी मना है और क्लास मिस कर दिया, right? Don't do that. Because एक क्लास मिस करना काफी भारी पड़ सकता है जहां पर के कॉन्सेप्ट्स पूरे ब्रेक हो जाते हैं. We are providing recordings, but live class का अलग मजा है यार. पूरा पढ़ोगे यहाँ पे ठीक से समझो. Very good. I'm getting answers. 245, 455, 245, 455. सब लोग कर पा रहे हो? आसान सा क्वेश्चन है, right? M is 35%. N is how much? N will be remaining 65%. किसका percentage निकालना है? We have total 700 ml. So what is 35 of this into 35 by 100? And this maths you can solve. 100, these two cancel. 245 ml is the value. आसान है सबके लिए. N कितना होगा? Total 700 ml. So what should be N? Yes, 355 or 455? 455 बिल्कुल होगा. ऐड करोगे 7 आना चाहिए. आ रहा है तो ठीक है. सब कर पा रहे हैं क्वेश्चन? Okay, so this is 700 into 65 by 100. Same thing you can do. Simple question. Easy itna? Great. So let us progress to the next thing. Now the next discussion is on a new term for you. Note down. Percentage weight by volume. This is a completely new term. Percentage weight by volume. What is meaning of percentage? Whatever is present in 100. So if it is weight by volume, what is unit of volume? ml. What is unit of weight? Weight and mass treated same in chemistry. Clear up to this? So percentage weight by volume is defined as in 100 ml of solution, how many gram of solute is present? Read it one more time. 100 ml of solution, how many gram of solute is present is known as percentage W by V or percentage weight by volume or percentage weight by volume. It is written in different ways. So I'm mentioning all possible ways in which you can find this question. All right. Percentage W by V, percentage WT upon VOL, that is weight by volume, or percentage weight by volume, right completely. It's the same thing. It is defined as 100 ml solution, how many grams of solute? These words are important. Solution, solute. Don't think solvent is written. Read things very, very carefully. How many understand this definition and this line, like what is written there? Amount of solute in 100 ml of solution is known as percent weight by volume. Please type 1 in chat box, sir. We understood. Very good. Those who have understood, please type 1 in chat box. All right. Excellent. Mind-blowing, super. Now, Kamini has a doubt. Yes, Kamini.
Sir, here weight will be of solute and volume is of solution.
Correct. 100 ml of solution, how many grams of solute? That's a definition. Okay. So volume of solution and weight of solute.
Yes, sir.
Okay.
Thank you.
Welcome, Beta. Very good, Kamini. See, she's asking her doubts. This is very, very important for each and every student. If you are coming across any doubt, feel free to discuss doubts. That is why we are keeping these class sizes not too big where you can't ask doubt, right? You'll be simply sitting for the whole class and then you will get a chance to ask doubt. No, we help you to solve your doubts within the class itself. Immediately, if it comes, you can always discuss and solve. Yuvraj.
Sir,
Yeah, beta.
here we will get in grams, na, sir. Then if it is solute is a liquid, then
If solute is a liquid, then percent weight by volume is not a measure. Then percent volume by volume we are going to use. That's a very good question he has asked. So Yuvraj's question is, what if solute is also a liquid and solvent is also a liquid? Then I will not prefer percent weight by volume as a unit. I will prefer percent V by V as a better unit. Clear?
yes, sir.
Okay. Good question. Now come back to this. And everyone understood this. So I will connect you with the previous question once again. This question. So go back to this question. 90 gram glucose in 250 ml of water question. Can you recall this question we have done today's class initially? 90 ml of glucose with 250 ml of water question. Let us try this question for percent weight by volume case. Okay. So 90, I'm sorry. This is 90 gram of glucose is there in 250 ml of water, right? So can you try for percent weight by volume? Is there any possibility? But there are small catches there, right? So you have to be very, very careful. Let's see those who can solve. Okay. 90 gram of glucose, 250 ml of water. Okay, so the biggest question here is, do we know the amount of solute? Yes, we know this is the amount of solute. The next question is, do we know what is volume of solution? Volume of solution, do we know? Please type yes or no in chat box. Everyone. We don't know. Very good. We don't know. Mohammed is mentioned, we don't know. Okay. Correct. Since we don't know volume of solution, can we use percent weight by volume in this case? So 250 ml, you are mixing 90 gram of glucose. Definitely there is some change in volume. Okay, let us suppose they give you that the volume of solution after mixing glucose becomes, for instance, let's say it becomes 300 ml. If they have mentioned, once you added this, it has become 300 ml. Reasonable? Think about it. Then can we solve this question? Yes or no? Can we solve this question now when we understand this line? Please answer yes or no. Very good. So what will be my answer? We have 300 ml of solution which carries 90 gram of solute. Definition says 100 ml of solution has how many grams of solute? So what shall be my answer? 300 has got 90. 1 has got 90 by 300. So 100 has got how much? 90 by 300 into 100. That comes out to be 30%. So my answer is 30% W by V. That shall be your answer. I think this must be clear to everyone because this is very, very fundamental and we have proper clarity on this question. If it is clear, you may type 1 in chat box. Sir, this percent weight by volume we have understood. What is meaning of it? Great. Okay, now let me check whether you are revising your notes or not. Few classes back, I have talked about a term which is known as this. Dilute and aqueous. Can you recall these two things? Dilute and aqueous. So what is dilute and what is aqueous? Let's see how you remember that. If you're revising your notes on regular basis, which you should do. So it's very simple. Let's say you're getting classes of chemistry. So the day you are doing chemistry class, after the class itself, you can do revision. That's really great. If somehow you are not able to do, then please do it before coming to the next class. But minimum revision is needed. So what is the difference in dilute and aqueous? Who will answer? I want a person to come on mic and answer. So raise your hand. If you know that, I'll invite you on mic as co-host and you can answer. Okay, he is going to answer. Okay, so let me make co-host. Yeah. Yes, he. Yeah, here. Can you answer?
Sir, the volume of solute is less than the solvent.
Volume of solute is less than or very, very less than?
Very, very less than.
Very good. It is so less that we can ignore as if it is not there. Very good. Okay. Now, Yuvraj, you please answer. If I add for dilute case volume of solute plus volume of solvent, can I ignore volume of solute?
Sir, can you repeat it?
In case of dilute solution, can I ignore volume of solute because it is too small and say that volume of solvent is almost volume of solution itself? Is this line clear or not? Correct or not?
I think so. No, sir.
No, it is yes. It is yes, actually. If it is dilute case, when volume of solute is too small, you can ignore it as if it is not making any significant change. Okay. That is for highly dilute solution. We can always do that, right? So if highly dilute solution, we can say that volume of solute is very, very small in front of other one. And hence our answer is that, yeah, I'm sorry. So what will be our answer? Our answer will be that volume of solute is very, very small unit of volume of solvent, and hence, just a minute. Then we can say volume of solvent itself is volume of solution. Let me just. Okay. Sorry. Is it clear? Any problem with this? Any issues in this? So we say volume of solute plus volume of solvent is volume of solution. And this is very, very small. So if this is almost nil, too small in front of solvent, then we can say solvent and solution are almost similar or on the similar lines. Is that okay? Is this clear to everyone? Yes. Now come to the next part. Next is about aqueous solution. Who will tell what is aqueous solution? Raise your hand. Let me check. Are you revising things or not? Kaumudi has come on mic earlier. Anyone else? Yuvraj has come earlier. Anyone else? I want new volunteers. He has already come. Other students. Baki लोगों को मौका मिलेगा. Paridhi is here. Paridhi, can you answer? Paridhi, you're in session. Can answer? Okay, let me choose the next candidate. Ojas, can you answer? Ojas, what is aqueous solution? You can unmute and answer. नहीं. Okay. एक काम करो यार, आप अपने कैमरास ऑन करो पहले तो सारे. आप हो यहाँ पे कि नहीं, पहले मैं चेक करूँ. हैं सारे लोग यहाँ पे. Okay, Kritin want to answer. Yes, Kritin.
But an aqueous solution is anything that which is mixed in water. So it is a
Very
solvent
good.
which is water.
Very good, beta. So when solvent is water, you can consider this to be aqueous solution. Excellent. Okay, so I hope this is clear to everyone. Right. Let us proceed further and discuss other things. Next. Any problem in this whole discussion? Up to this, everything is clear? Right. So this question, you can take a screenshot. I will not solve this question with you right now. I would like to give you as an home assignment and we'll proceed further. So everyone, please take a screenshot of this question and try to solve this question at home. This is a kind of home assignment for you. Done? I request mentor teacher also to take a screenshot and share in the group so that they can have this if they are not taking screenshot by any chance. Let's proceed further. So there are certain other units of concentration, and one of them which is highly famous is molarity. Note down the heading, molarity. Right? What is definition of molarity? How exactly we define molarity? So molarity is defined as in 1 liter of solution. In 1 liter of solution, how many moles of solute do we have? How many moles of solute do we have? 1 liter of solution is 1000 ml of solution. So it is defined as 1000 ml of solution. How many moles of solute do we have? It's called molarity. Correct. Read the question carefully. And if we want to define in terms of formula, molarity is represented by capital M, which is moles of solute divided by volume of solution in liter. This is the formula. I will prefer that you don't go with the formula approach. I will prefer that rather than this, you understand this line. Okay, this is better method. So first you please note down this. Moles of solute in 1000 ml of solution or 1 liter of solution is known as molarity. Molarity, which is represented by capital M, is defined as moles of solute upon volume of solution in liter. So all of you please note down this line and then we can proceed further. Okay. Very good. Right. So this is clear. Let us apply this to the question that we were solving earlier. The question we were solving earlier was 90 grams of glucose was mixed with 250 ml of water. Final volume became, let's say, you said 300 ml solution. Correct. So can we find for this setup what will be the molarity? Let's try out. Take your time. Everyone, start solving this question, please. Here. Look at the definition here. Moles of solute upon volume of solution in liter is the formula. Or in 1 liter or 1000 ml of solution, how many moles of solute are there? That is called molarity. So, what are the moles? First of all, what is solute? I can say this is your solute here. This is your solute. This is solvent. Solute amount is 90 gram. How many moles of solute do we have? 90 divided by molecular weight is 180. That came half mole. This calculation we have done earlier. This is moles of solute. Likewise, what is moles of solvent we have? It is 250 divided by 18 moles. This much information all of us carry. Isn't it? If this is clear, please type 1 in chat box. So this is fine. This is okay. We understand this much. Let me do a concept clarity poll. Yeah. If you listen, you'll understand that's completely assured here. Okay. Okay, so almost 89% students, 88% students are attending and understanding the whole thing. No problem. Others will also understand. Only thing is you have to be very, very attentive in the class. What is the definition of molarity? If you bring it here. So definition of molarity is written very, very simple definition. That is, you have to tell. Just a minute. Okay, there's some problem. Right. So we can write it. Definition of molarity is written as 1 liter solution consists of how many moles of solute? That is the definition. What is our situation right now? In the current situation of question, 1 liter or we can say 1000 ml. That's the same thing exactly, right? So in our question, 300 ml of solution has half mole of solute. This has half mole of solute. Can we do it for 1000 ml? Yes. Try doing, everyone. Simple maths, unitary method. I expect all of you know that how to do that. Please do that and get me the final answer. 300 has half mole. So 1 will have half by 300. So 1000 will have half by 300 to 1000. Can you do the maths and get the final numbers? Let's try. Very good, Vaibhav. Aridhi, Aradhana. Aradhana has given answer also 0.16. Let us check. So your final result should look like half divided by 300 into 1000 is the final molarity, which if you solve it carefully, these two zeros gone. Okay. This 2 comes down. This is 10 by 6. This mass part, I think you can take care of, or 5 by 3. Right? Can you get the final answer? $166.66. No, do it carefully. Moles upon volume of solution is in liter, not in ml, liter. Yes. Take your time, there is no hurry. Doing correct is more important than doing fast. Okay? Doing correct is more important than doing fast. So what's the answer? 1.66, I think, or 1.67 is the molarity. Molarity. So its symbol is capital M. How many of you are in condition to understand molarity? So this is clear now. I can solve questions on molarity. Basic questions I can solve at least. Type 1 in chat box. This is clear. All clear till now? Very good, Paridhi. All clear. Ishita, Vaibhav, Mahati, Medini. Excellent. Excellent. All clear. All clear. Amazing. So what we have understood that if you're given, so if you want to solve molarity of a solution, you can say moles of solute upon volume of solution liter. Now think in another way. Can we say if I multiply these two things, I can get moles of solute? If I multiply molarity of a solution with volume of solution in liter, I will get moles of solute. That's also fine. Okay, so let me rewrite this statement once again for you. So I'm saying that molarity multiplied by volume of solution in liter is equal to moles of solute. Shall be clear? Very simple thing. Easy. Check this line. Check this line. Molarity into volume of solution is moles of solute. Okay. Great. So if this part is clear, we can solve many more questions on this. But I hope this much is very basic fundamental thing that we have done so far. Okay, if it is clear, please type 1 in chat box, all of you. Right. And we proceed to the next thing, but since you have done too many things so far, I would like to have a quick revision or recap of what all we have done, then we proceed further. So today's class, I'll extend by 5 or 10 minutes. There are a few things that we completed, and you keep solving home assignment 1. Other assignments also will be given. It's the same booklet, it is there. I'll tell you later. But first, let me take you again through the whole class, what all we have done in today's session. So this class started with this particular recap. Percentage by weight, percentage by volume, mole fraction, solute, solvent, solution. Conservation of mass for solution holds true, but conservation of volume is not holding true. Then we talked about this question, 90 grams of glucose with 250 ml of water. What is solute? What is solvent? What is mole fraction? So we got moles of each. What is percent by moles? Mole fraction multiplied by 100. The definition already we know. Then we talked about total weight of solution if reaction is occurring in a vessel. So we added both the components. We got total. Why they have used this word closed vessel? Because if, let's say, some gaseous component is there, it can escape the given vessel. Then we came to this thing, which is percent by weight of glucose and percent by weight of water. And then we solved another interesting question, which was a solution was given, which was cooled and 50 grams of solute was precipitated. What is the percent by weight of the remaining solution? So you started with 500 grams. So let's say this is the solution. Total 500, there is 400 and 100 component. Later, this 400 solvent remain as it is. This part, some portion got precipitated. This remained 50. So initially your percentage was 100 divided by 500 into 100. Later it became 50 divided by 450 into 100. This is simple maths we have done. I think this is very reasonable explanation, which explains you everything very, very proper. This was clear. Then after this, we came to this question, which almost everyone has solved in the class. So I don't think anyone has problem in this particular question. Then we came to revision of dilute and aqueous concept, which many of you know, but I request that please revise. We came to the next thing, which is percent weight by volume. In this, few students, one or two students struggled a little bit, but later everyone was comfortable. Definition is 100 ml of solution. How many grams of solute? 100 ml of solution, how many grams of solute? So if we solve the same question of 90 gram of glucose with 300 ml of solution, then we get answer as 30%. 30% W by V. That's what I have written. Okay, 30% W by V. Then I gave you this question as your home assignment. And after that, we have discussed about the same question, which is in terms of molarity. What is the molarity definition? 1 liter of solution, how many moles of solute? And then we have solved the same question of 90 gram glucose with 250 ml water, giving you 300 ml of solution. What is its molarity? And I think this question almost everyone answers, right? Now, the next thing, yeah, what is unit of molarity? Molarity unit, read it once again. Number of moles of solute in how many liter of solution? 1 liter of solution. So what should be unit? Gram per liter or moles per liter, beta? Not gram per liter. It should be comma the moles per liter. Clear? Okay. So I have a question for all of you to solve. And I will ask this question here itself. Let me just add one page. And let us try this question. Yeah, it's visible. Fairly enough. All right. So question here is percent weight by volume and molarity. Percent weight by volume and molarity are linked as this. What shall I multiply? Read it carefully, try to solve. Take your time. There's no hurry. And this question you can spend 1 minute. Think and solve. Percent weight by volume and molarity. Correlation of these two things. So we know both the definitions. We can use our understanding and we can give the answer. Yes. Don't be in hurry. Yuvraj has messaged 100. No, Yuvraj. Think a little bit more deeper. Go to the definition. Percent weight by volume is defined as 100 ml. How many gram of solute? 100 ml of what? Solution. Okay. How is molarity defined? Molarity is defined as, yes, 1000 ml. How many moles of solute? 1000 ml of what? Solution. I think these two lines are clear. Use this and try to answer. What kind of correlation be there? Molar mass of substance, Anumanya Jaiswal. Maybe NA, PG Krishna. Don't answer maybe beta. If you're not sure, don't answer. Think and answer. Try to answer correctly. Everyone participate and try to answer. Okay, just see here. This is 100 ml of solution. This is 1000 ml of solution. Don't you think if I want to do something and correlate these two things, I should make them both 1000 ml or both 100 ml at least? Correct? So if one thing is 100, other is 1000, we can't correlate, right? How many understand this line? That we have to at least do something for 1000 and 100. Yes or no? Great. So can we do one thing? That this is for 100 ml of solution. This is defined for 1000 ml of solution. Let's do one thing. If I multiply this number by 10, think about it. If I multiply this number by 10, do you think this will be the amount in 1000 ml of solution? Simple or not? Currently, it is 100 ml of solution. What is a gram of solute? If you multiply by 10, it will be amount in 1000 ml of solution. Is that clear or not? If yes, please type 1. First, you answer this. All of you. If you multiply 10, will this number become in 1000 ml of solution? This is a very simple thing I'm telling. If you understand, please type 1 in chat box. If those who are finding it difficult, please type 2 in chat box. So nahi samajh mein aaye. क्या बोला आपने? 100 ml सॉल्यूशन में 100 ml सॉल्यूशन में आपके पास लेट्स से x ग्राम ऑफ सॉल्यूट है। जैसे इसे 10 टाइम्स करोगे, आप 1000 ml बोलोगे तो ये कितना हो जाएगा? 10x हो जाएगा। वही बोल रहा हूं मैं, बिल्कुल सही बात। सभी को समझ में आ गया? बहुत स्मार्ट है आप सब, वेरी गुड। या युवराज, यू हैव अ डाउट, प्लीज आस्क।
Sir, if 100 ml will give us x grams of solute, then 1000 ml should give us 10x grams of solute, na sir?
Correct, correct. That's what I'm telling. So what you
10x
have done,
grams.
correct. So when you multiply the number with the 10, okay, this whole thing is 1000 ml solution in a way. Think
Yes,
about it. That's what I've said, isn't it?
yeah.
You're also clear. So what I'm telling is that, come back to this discussion once again. So percent W by V is in 100 ml of solution, how many grams of solute is there? Let's say we multiply 10 on this. We multiply 10 on this. What is meaning of it? In 1000 ml of solution, how many grams of solute are there? It is the meaning or not? This number, if you divide by molecular weight of solute, don't you think it is moles of solute? 1000 ml of solution, how many grams of solute already we have? If I divide by molecular weight of solute, I get moles of solute. And what is this moles of solute in 1000 of solution known as? Molarity. So if you do this, this is automatically equal to this thing. So in a way, can we understand that whole thing? Percent W by V is defined as molarity into molecular weight of solute divided by 10. Think about it. It is not difficult. If you give yourself some thought, you will be able to figure it out. Just hold on for 5-10 seconds. Read the statement. In 1 liter of solution, how many moles are there? In 1 liter of solution, how many grams are there? If 1 liter of solution, these many grams are there, divided by 10 is, in 100 ml solution, how many grams are there? That's what is called percent W by V. Think, spend some time. Anumanya, yeah. What's your doubt? Please ask.
सर इसमें सर वॉल्यूम तो सर नीचे में है ना सर, अगर हम लोग 10 सर ऊपर में मल्टीप्लाई करेंगे सर वॉल्यूम तो सर और 10 मतलब क्या होता है 1/10 पार्ट उसका हो जाएगा
फिर से सोचो,
सर, और
फिर से
10
सोचो,
सर नीचे
ध्यान से सोचो, ऐसा सोचो। एक बहुत सिंपल सा एग्जांपल देता हूँ मैं। चलो एक नंबर डाल देते हैं यहाँ पे, अगर कुछ लोगों को दिक्कत आ रही है अभी। ऐसा सोचो, लेट्स से परसेंट W by V आपका x है, ठीक है, मान सकते हैं। अगर परसेंट W by V x, इसका मतलब क्या हुआ? अगर आपके पास 100 ml सॉल्यूशन है तो उसमें कितना सॉल्यूट होगा? आंसर करिए जल्दी से। अनुमान्य,
यस सर,
कितने ग्राम सॉल्यूट
सर।
होगा? अगर परसेंट W by V की वैल्यू x है तो कितना सॉल्यूट होगा 100 ml सॉल्यूशन में? x ग्राम, करेक्ट?
ओके सर,
डेफिनेशन तो x ग्राम ही ना। तो 100 ml में अगर x ग्राम होगा, अगर मैं इसको 1000 ml करता हूं तो कितना हो जाएगा वैल्यू? 10x ग्राम। यहां तक समझ में आता है? और 10x को अगर मॉलिक्यूलर वेट से डिवाइड कर दोगे तो क्या आएंगे? मोल्स ऑफ सॉल्यूट आएंगे कि नहीं?
ओके,
ठीक है, और ये मोल्स कितने में है? किसमें? 1000 ml ऑफ सॉल्यूशन में है कि नहीं? और यही मोलैरिटी है। तो ये x क्या था आपका? x ही तो परसेंट W by V था। बात समझ में आती है? ध्यान से सोचो,
यस सर,
स्टेटमेंट में रख के, वैल्यू रख के सोच लो एक बार, अगर दिक्कत आ रही किसी। एक बार फिर से देखना, दूसरे तरीके से दिखा दो इस चीज को। लेट्स से मोलैरिटी से शुरू करते हैं। मान लीजिए मोलैरिटी आपको गिवन है। मोलैरिटी की डेफिनेशन क्या होती है? 1000 ml सॉल्यूशन में कितने मोल सॉल्यूट किए हैं, यही तो मोलैरिटी होती है बेटा।
यस सर,
क्लियर है? अच्छा चलो, 1000 ml में इतने मोल्स हैं, अगर मैं इसको 10 से डिवाइड कर दूं तो क्या हो जाएंगे? 100 ml के मोल्स आ जाएंगे।
यस सर,
यस और नो? अरे 10 से डिवाइड करोगे तो 100 ml के मोल्स आ जाएंगे। मोल्स किस चीज क्या है आपके? सॉल्यूट के। अगर आप उसको मॉलिक्यूलर वेट से मल्टीप्लाई करते हो तो मास आ जाएगा।
यस सर,
किस चीज का मास आया? सॉल्यूट का। कितने में आया? 100 ml सॉल्यूशन में आया।
100
और उस मास को बोलते क्या है? उस मास को क्या बोलते हैं?
क्या था?
परसेंट वेट बाय वॉल्यूम ही तो बोलते हैं डेफिनेशन के हिसाब से। बात समझ में आती है?
यस सर,
दोनों तरीके से चेक करके देखो, सेम आंसर होगा। ठीक है, आई होप नोबडी हैज दिस कंफ्यूजन नाउ। आई हैव एक्सप्लेन बोथ द वेज, इट शैल बी वेरी वेरी क्लियर नाउ। अगर समझ में आती सबको तो प्लीज टाइप 1 क्विकली इन चैट बॉक्स। सोचो। या बायो क्लास बेटा थोड़ा सा 5 मिनट हम डिले करेंगे आज, ठीक है, आप ब्रेक लेके फिर शुरू करेंगे, तो ये थोड़ा सा मैं एक्सटेंड कर रहा हूँ 2-4-5 मिनट, देन विल प्रोसीड फॉर द बायोलॉजी क्लास। कुछ लोग थक गए केमिस्ट्री से। चलो कोई नहीं, अभी मैं काम करता हूँ, आपके डाउट्स लेता हूँ, अभी यहीं पे होल्ड करते हैं। यहाँ तक समझ में आ गया तो अच्छा है। मोलालिटी हम लोग नेक्स्ट क्लास में शुरू कर लेंगे, ठीक है। मोलालिटी बच रहा है, बाकी मैंने सारा करा दिया आपको। सो मोलालिटी विल डू इन नेक्स्ट क्लास, नो प्रॉब्लम। लेट अस टेक अप योर डाउट्स। आज की क्लास में क्या क्या डाउट्स है पूछना शुरू कर। चलिए, रेज योर हैंड, माइक पे आइए, डाउट पूछिए जल्दी। जिनका भी डाउट्स है, क्विकली यू कैन कम एंड डिस्कस योर डाउट्स वन बाय वन। ओके, फाइन। किसी का कोई डाउट नहीं है? सबका डाउट क्लियर कर दिया? क्या बात है, बहुत ही बढ़िया। कोई भी डाउट नहीं बच्चे? किसी का भी डाउट नहीं? अच्छा, रिवाइज भी कर दिया गया ना आज तो पूरा? ठीक है, देन जिनकी बायो क्लास है, सो बायो क्लास विल स्टार्ट, थोड़ा सा आज लेट कर रहे हैं, 6:15 पे शुरू कर लें, क्योंकि अभी 6:02 है, अभी आप लंबी क्लास चलेगी थोड़ा, तो आप थोड़ा रेस्ट लीजिए, एंड देन 6:15 शार्प वी आर गोइंग टू स्टार्ट बायो क्लास। इज इट ओके? राइट? ओके, great, thank you. So the same link will work for biology class, right? मोरालिटी नहीं बेटा, मोलारिटी। मोरालिटी अलग चीज हो गई, मोरल वैल्यूज पे चले गए आप। मोलारिटी नॉट मोरालिटी, स्पेलिंग ध्यान से रखो। अभी एक और मोलालिटी, कंफ्यूजन होगा बहुत सारा। अभी हम लोग ने क्या पढ़ा आज? मोलारिटी, RITY। अगली क्लास में पढ़ेंगे मोलालिटी, और अभी एक बच्चे ने लिखा है मोरालिटी। मोरालिटी कुछ यहाँ पे केमिस्ट्री में मोरालिटी नहीं होगा, सोशल साइंस में पढ़ेंगे। एनीवेज, सो लेट्स क्लोज दिस डिस्कशन, राइट? या, थैंक यू।